Hello and welcome to my lab. My name is Suleman. I am CCNA and CCNP. This is my first video I am going to share with you. It's about IPSec over GRE Tunnel. As we all know, we are very familiar with typical site-to-site VPN connection, and we are also aware of their usage in our daily routines. But in this video, what I am going to share with you is that I am going to take it one step further, and using the existing IPSec tunnel, we are going to implement our GRE tunnel, which is generic routing encapsulation, and run our EIGRP, OSPF, and RIP protocols, which are interior routing gateway protocols. So it's a great technology, and I hope this video will help you illustrate some of our day-to-day concepts, so that we can do it and implement it in the real time. Okay, so let's get started. What I have done in this video, I have divided this in two phases. Basically, first we have to create site-to-site VPN connection using IPSec configuration, and these are the steps we are going to follow. The second step would be to build our GRE tunnel and run our OSPF routing protocol over it. So let me show you the interfaces which are connected to the internet and this topology. Okay, so you can see that fast Ethernet 0/0 is connected to the internet on the site 1, and same is the case with the site 2. Fast Ethernet 1/0 are connected to the local area networks on both sides. Okay, so let me turn off that interface option. It create a mess out of my topology. Let's see, okay, so let's get started. Let me bring up site 1. First step is to create basic connectivity. So interface FA0.0 IP address 50.1.1.2. The internet side is 1, so on our router side we give 2. 255.255.255.252. Notice here that the IP address scheme is with 30-bit network mask, so we have to give the network mask accordingly. Okay, no shit. Okay, so 1/0 IP. This is our local area network interface. 192.168.1.1. Okay. Do show IP interface brief. Okay, that's fine. Both our interfaces are up and running. So let's hop over to the site 2 router and do the same thing. side is 60.100.1.2. 1 is the internet side, so I 255.255.255.2. Okay, now shall bring up the interface. Interface FA1 is 0. This is our LAN interface. Let's give it a IP. This side is 172.168 with 24-bit network mask. 172.168. Show IP. Very good. So our both interfaces are up and running. Let's ping our service provider, the internet. .1. Okay, it's working. Let's do it on side 1 as well. 50.100. Okay, good, it's running. But if we ping the other side, which is 60.2 of this side to router, let's check that. It's failing. It doesn't know about this route, so we have to create a default route here. IP route 0.0.0.0. You can either direct it towards an interface or an IP address. In this case, we will direct it towards interface, which is fast Ethernet 0. This one. Okay. Good. On the other side. Let's do it now. Ping the other side of the excuse me, router. Yeah, it took some time, but it's now reachable and the ping is successful. Okay. That's good. Our basic connectivity, which is the step 1, has been accomplished. Alright, now with basic network connectivity in place, we are ready to move to our next step, which is defining our intrastring traffic using an ACL. So let's do that. Bring up site 1. Config. I'm going to use an extended IP access list. We use wildcard mask here instead of using subnet mask since it's an ACL. 172.168.1.0.0.0.255. Okay. Show IP access. So there we have our statement of the ACL. Permit IP this whole network to this network. It is whenever this network tries to reach to this network, we will use this ACL. After creating an access list, we are ready to move to our next step, which is to create an isakmp policy. So let's do that. Crypto isakmp policy 1. Authentication. We are going to use pre-shared mode of authentication, which is pre-shared key. Crypto isakmp key 0 Cisco address. Here we have to mention our RPS address, which is on the site 2. It's this one, 62.100.1.2. Okay. Crypto IPSec transform set. We will name it my set. I'm just going to use very basic setup of this VPN connection just for illustrative purposes. So you can use whatever hashing or encryption method you like. I'll use basic ones. SHA for hashing. Okay. Crypto map. My map. We will name it my map. 1 IPSec isakmp Notice the message popped up saying that this new crypto map will remain disabled until a pair and valid access list have been configured. So remember, we have configured an access list to define our interesting traffic. We are going to use that access list in our crypto map here. So let's use it, match address, and it said the access list number was 101. Okay, set pair on our pair address is 60.100.1.2. Set transform set, and our transform set name was my set. It has got all the encryption and hashing methods in it, so it's going to use that whatever we have mentioned in my set. Okay, so basically our crypto map is done. Now we need to apply our crypto map to an interface in order to take effect. So let's see which interface we are going to use. To make sure, we check fast Ethernet 0/0 is the interface going to the internet, so we are going to use this one. Okay, that's good. Just to make sure, interface FA 0/0 crypto map my map. ISakmp is on. So now that we have turned on the crypto map on our interface, let's check our settings. So okay, here is our crypto map. Crypto map name is my map. Pair address is this one. We are using the extended ACL 101 excuse me, which is permit this whole network to this network, and lifetime is this. All other settings are default. I haven't changed them to save some time, since this video is getting too lengthy, I think. And let's check our IP access list, since we have checked it. Okay, no need. So what I'm going to do here is pause the recording and hop onto the site 2 router and do the exact mirror setting over there, so in order to save time. Okay, we will come back and then we will continue with our phase 2. We are almost done with our phase 1. Okay, alright, welcome back. So I have done the crypto map setting on the router side 2, and now they are working. So let's check our setting. Okay, so here we can see that crypto map my one IPSec isakmp policy is in place. Here is 50.100.1.2, which is this one, site 1, and access list 101 is in place. So let's check our crypto map function. ping is successful. Let's see a crypto map configuration. Associations. QM idle active. So our VPN tunnel is up and running. You can see that 28 packets have been encapsulated. If we ping once more, that number will go up by the number of pings we send. So let's give it a try. Now check again. You can see that here previously it was 28 packets that were encapsulated and decapsulated, now 33. So it shows that our VPN tunnel IPSec is running great. Okay, with our core network infrastructure in place, we can now move to our second phase of this lab, which is to create GRE tunnel. So let's do it. GRE tunnel configuration is fairly simple and easy. With this command, we can create a GRE tunnel, which is tunnel 0 in this case, and as you can see, this message popped up telling us that the tunnel has been created, but the current status is down since we haven't configured anything. So let's quickly do show IP brief. As you can see, this tunnel 0 has appeared in the list of our interfaces. It's down. We need to configure an IP address here and some other configurations. Okay, let's give it IP first. 10.10.10.1. We are using 30-bit network mask here as well. You can see I am using this network on site 1 router and site 2 router. This site 1 router is 1 and the site 2 router is 2. Okay. Tunnel destination. First we have to give source, tunnel source. Our tunnel source is this interface, which is fast Ethernet 0/0. Let me show it to you. Which is going to the internet. and on the other side it is fast Ethernet 0/0 as well. So you have to remember this. Okay, just turn that off. Tunnel destination. Here we have to give the IP address of our peer router on the other end, which is 60.100.1.2. And since we are going to run OSPF on this tunnel interface, we need to do some extra tweaking so that OSPF runs fine. Ignore. This command I used here is to automatically find its path, since this tunnel interface is going through the internet, so we needed to automatically find its path. Okay, let's hop over to the site 2 and do the same configuration. Sorry, interface tunnel 0. Tunnel interfaces are in fact logical in nature. You can say like SVIs we used to configure for the VLANs, they are also logical in nature. So let's give it an IP address 10.10.10.2 252. Tunnel source FA0/0, and tunnel destination would be the peer address of our other router, which is site 1 router. Destination 50.100.1.2, and let's do the tweaking as well. IPOSPF MTU ignore. This command will help OSPF packets neat and clean. Okay, so you can see the tunnel is now up, and let's do another one. Tunnel path MTU discovered. Okay, so let's ping and check our connectivity. We are on the site 2 and we are going to ping site 1 router. Do ping 50.100.1. No, sorry, this is our peer address. We need to ping the tunnel interface, which is 10.10.10.1. Alright, good. We can ping the other side and vice versa. Now we have to encapsulate and secure our tunnel. So we will use the existing crypto map we used to create site-to-site VPN. The same configuration we will apply it to our tunnel interface, so that our tunnel data GRE tunnel data is secured. So you can, since I am inside the tunnel interface, I will type crypto map. My map was the crypto map name. Enable. Let's do it on site 1 as well. Crypto map. My map. Okay. Okay. So now we have set up a GRE tunnel. We have tweaked it according to our requirement, and we have binded it to our IPSec configuration. So these three steps have been accomplished. The last step is to run an OSPF routing protocol. Excuse me. Let's run our routing protocol. Router OSPF 1 network 10.10.10.0 and area, let's put it in the area 0. Okay, same thing here. Router OSPF 1 network 0. How many zeros? 3 zeros. Okay, 3 area 0. Note, when I press enter, we should be able to form the neighbors, and the OSPF neighbors should come up. Let's see. There we go. We have just gone from loading to full state, and we have found one adjacency neighbor with 192.168.1.1, which is site 1 router. Very good. Excuse me. Let's check the other side. Yes. Show IP OSPF neighbors. And you can see the neighbor adjacency, and state is full since it's a point-to-point connection.